Welcome to 4.3 extension video. This is the areas of composite figures, and this one's pretty easy, but at the same time you have to have a good eye for these shapes, so pay close attention and make sure that you are following along and doing the practice problems with me. There's not a lot to this. I'm on page 172 in your book, and there's 2 examples, so it should be pretty quick. First of all, composite figure. Basically, it's made up of triangles, squares, rectangles, and other two-dimensional figures. And so an example would be a couple of those different shapes put together. So here's a couple examples I'll draw for you. So here's a couple examples, like I said. If you had a shape like this and you didn't actually see these little dotted lines, it would just be a shape. So let's say this is like a house. You want to find the area of this wall of the house. Well, you can split it up into 2 different shapes, this being your triangle and this being your rectangle. And then the shape over here, the composite figure, you could break this up by putting a line right here, and this being your square, and this one being your trapezoid. Now, because we know how to find the area of figures like a triangle and a rectangle and a square and a trapezoid, we could find the total area of all of this composite figure by splitting them up in if we had numbers. So to find the area of the composite figure, you'd separate the 2 figures with areas we know how to find. And like I said, we know how to find a triangle. We know how to find a rectangle. And then you would add those 2 areas together. So you'll see an example the next page with example 1. Example 1 is finding the area of a composite figure. Okay, so if I'm given this composite figure down here, it says find the area of the figure. You can separate the figure into a rectangle and a trapezoid. Count the grid lines to find the dimensions of each figure. Then find the area of each figure. So they're showing you that this area right here is a rectangle, and this would be a trapezoid. So I'm just going to take a different color, and I'm just going to separate the 2 shapes. Now, one thing that you have to remember is there might be a number of different ways we could do this. I mean, technically speaking, we could separate it and make a triangle here and a triangle here, but that would be a little bit more work on our part. We don't really need to do that, so you wouldn't necessarily do that. But just remember, there's multiple ways to do that. So the first thing you're going to start with, it says you can separate the figures. We did that. And then count the grid lines to find the dimensions of each figure. So I'm going to count. I've got 1, 2, 3, 4 units up here. So I'm just going to write 4 units. Then I've got, I'm just focusing on my rectangle. Then on my rectangle, if I'm going down, I've got 1, 2, 3, 4, 5, 6 units. So to find the area of this rectangle, I would just say my area equals length times width. So I've got 4 units times 6 units. So I have 24 units squared. That's just for my rectangle. Now I'm going to work on my trapezoid. So for my trapezoid, I've got to look and see how many units do I have for my my base. And I have 2 bases. I can already say, well, I counted 4 units up here from this distance. Obviously, this distance is the same, but you could always recount them if you wanted to. So my base 1, I'm going to go over here, 4 units. Base 2, I've got 1, 2, 3, 4, 5, 6, 7, 8 units. So base 2, I have 8 units. And then if I'm looking at my height, I've got 1, 2 units that I go out, and I can make a little line there to show where I'm going. So I've got 2 units for my height. So now you have to find out what is the area of our trapezoid. Well, this is our rectangle over here. So our trapezoid, let me fix my A here. So my trapezoid would be area equals 1/2 height times base 1 plus base 2. So I'm going to fill in all my information. I've got 1/2. My height is 2 units. My base 1 is 4 units, plus my base 2 being 8 units. My next A, I leave my 1/2, I leave my 2, I do my parentheses first. 8 plus 4 gives me 12. So now I can, excuse me, now I can go through my next step and say 2 times 12 gives me 24. And then my last A would be 1/2 times 24, or I could also say 24 divided by 2. It would be 12 units squared. Now you're not finished with this, because what we've done here is we have found an area for, oops, that 2 is not part of it. We found an area for our trapezoid, and we found an area for our rectangle. So now what you need to do is you need to say how many are there total in the whole figure, and all you do is you say 24 units plus my 12 units, should give me 36, I'm running out of room here, units squared. And this would be your total answer. Now, you say to yourself, is it reasonable? Well, you could obviously just go in here and start counting. How many actual units am I finding? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So there's 34 full units. And then I've got 1/2, 2/2. So that would be considered 1. Now I've got 35. 1/2, 2/2. So now I have another full. So yeah, I have about 36 units squared. So it does check. And that's how you would find the composite figure, the area, using counting grid lines that were worth units, not any type of measurement. Example 2 is a real-life application, and you're finding an area of a fairway between 2 streams on a golf course. It's kind of a cool real-life application if you actually need to find area of, a plot of land. It's kind of cool because when Mr. Taylor and I were building our house, we found plots of land and how it was split up into acres, and you could see aerial views and how they had it panned out. And this was an exact example of what it actually looked like for us. So it was kind of cool to compare those type of real life applications. So here we go. I'll show you the pictures of them, and then we'll find the area of the composite figure by splitting it up into 2 different shapes we know the area of. So the directions say to find the area of the fairway between 2 streams on a golf course. There are several ways to separate the fairway into figures whose areas you can find using formulas. One way is to separate it into a right triangle and a rectangle. Identify each shape and find any missing dimensions. So this is the figure that we're talking about here. And as you can see, the fairway goes straight up and then it would curve around. So what they're telling us to do here is one way, and again there's multiple ways that we could do this, but one way is to separate it into a right triangle and a rectangle. And all they do is just draw a nice line straight down and they separate it. So now I have this rectangle and a right triangle. So now I'm going to redraw that over on the right and show you how to find out what everything is. Because look, they give us all the dimensions right here. We just got to kind of put them in place. Okay, so now I've got my picture over to the left. I've got my area of and my rectangle and my triangle that I'm going to set up. Now here's the tricky part. I'm going to fill in what they have for their numbers. So this up here, this line is 40 yards long. This one here is 50 yards. So this line right there is 50 yards. This one down here is 40 yards. Then they're telling us that this line here is also 40 yards. And then they also tell us that the line way down here is 40 yards. And then this long one is 70 yards. So they've given us all this information. Now let's see what we can plug in. So the rectangle. Let's find the area of the rectangle. If we know that area equals length times width, and we know that the length and the width, we've got 70 yards and 40 yards. So we should just have 70 times 40. And multiplying this quickly, you should say 7 times 4 is 28. And then we add both of the zeros that were left in our problem. So we should get 2,800 yards squared. So now our triangle. So now we found the area of this rectangle. So now we have to find the area of the triangle. So let's start off with writing our area equals 1/2 base times height. Area equals 1/2. Let's find our base and let's find our height. Well, if this is our triangle, and it's a right triangle, so we can say that is a right triangle right there, we are given a line right here that we don't need to worry about. And we are giving 40 yards for our base. So we can add in our 40. But what's our height? They didn't give us. This is an unknown line right here, so we have to figure out what that is. So we need to look at everything we have. We know from this point to this point is unknown, but we know the entire line is 70 yards. Then they told us that this line right here is 40 yards. We didn't use that in the above. We didn't use that when we actually did out the rectangle because we didn't need it. We had a length, or we had a length and a width, which was fine. Well, if this is 70 yards over here, from here to here, and we know that this is 40 yards, what would the rest of our line be for that rectangle? You could do it two ways. You could say 70 minus 40 gives you 30. So if that makes sense, we should be able to say, well, 40 yards plus 30 yards gives me 70 yards to complete that whole line. So what that tells me is that this line right here is actually 30 yards. And that would be my height. So I could add my 30 right there. So continuing on, I have 1/2. 40 times 30. 4 times 3 is 120. Or I'm sorry, 4 times 3 is 12. And then we add in our 0 and our 0. So we should get 1,200. And then our last thing is we have to multiply it by 1/2 or divide it by 2. Either way you want to do it. You come up with 600 yards squared. So our last step is to say 2,800 yards squared plus 600 yards squared should give you 3,400 yards squared. So my area for this composite figure of the fairway is 3,400 yards squared. Your practice problems for 4.3 extension are big green, page 173, numbers 1, 3, 5, and 7. And because there were no on your own problems in here, I'm going to do a couple right after this page. So you are completely done doing the video unless you'd like to see a couple practice problems worked out. Continue to watch. If you're all set, you're all done. So for this extra practice, I'm going to do the other opposite problems from the book that aren't your practice problems, numbers 2, 4, and 6. This is number 2, and we have a shape that we can easily see that we could split, that we could split right down the middle and make 2 trapezoids out of it. So in order to do this one, you're going to have to find the area of both of those trapezoids by counting out our units. So let's start off by saying how many units we have on base 1. On this top one, we'll start with the top trapezoid. We've got 1, 2. Let me get a different color. I'll stick with my blue. Alright, I got 1, 2, so 2 units here. Then I'm going to go right down to my base 2. And I'm going to say I've got 1, 2, 3, 4, 5, 6 units. And then I'm going to figure out what my height is. Well, my height would be this line to this line. I could say I've got 1, 2, 3, 4 units. Now from right here, what's nice about this shape is we can say it's a mirror image of the other one. And basically, everything down here is the same as everything up there. With that being said, I can find out what my area up top is, and then I can find out what my area on the bottom is just by doubling it. So let's start this out. I've got area equals 1/2 times height, plus base 1 plus base 2. I'm sorry, times base 1 plus base 2. Sorry about that. It's getting late. 1/2 my height would be my 4 units. My base 1 would be my 2 units. And my base 2 is 6 units. So area equals 1/2 times 4. 6 plus 2 is 8. 1/2 times 32, because 8 times 4 is 32, and then just breaking that in half, I should get 16 units squared. Now, like I said, this shape right here is the exact same one as that one, so all I have to do is double my units squared, and I should come up with an answer of 32 units squared. And if I went through and I counted each one of these units separately, it would come out to be 32 units squared. For number 4, I'm given a shape that looks like this, and I could probably split this a couple ways. I could take a pen and go down and say, well, here's a triangle, but then I still have more to deal with. Could I split it into a triangle there, another triangle, and then I have a square? Again, there's endless opportunities of what you can do. Just try to do it where it's the easiest for you and the easiest to find and end up with the area. So I'm going to split it right down the middle this way, and I come up with 2 parallelograms. We know that the area of a parallelogram is base times height. We learned in 4.1. So let's see if we can come up with that. Well, they give us a base of 12 and a height of 5, so yeah, we've easily got that. And again, this is a mirror image. We've got 2 parallelograms that are exactly the same size. So I'm just going to go ahead and solve one of them. Base times height. My base is 12. My height is 5. And if 12 times 5 is going to give me 60, and this is feet, and it'd be squared. Now if we're going to double this, we would just say 60 plus 60 equals 120. So right now, this information covered just that parallelogram. By doubling it, I'm also covering that parallelogram and getting an answer of 120 feet squared for the entire thing. So it's nice how it does work out that way. It doesn't always work out that way, but in this situation it does. We only had to find the area of 1 and double it. Now in a shape like this, I don't have any mirror images, so I have to actually do a couple different areas. If I'm given this, I know right now I can just take a line and I can separate it into a square and into a trapezoid. So you have to use like a little bit of information from both of them. Let's start off with our square. We know that the area of a square is side squared. Oops. So I'm going to fill that in. I've got 10 squared, or 10 times 10 equals 100, and it's inches squared. So that took care of this shape right here. I'm done with that. That equals 100 inches squared. Now to do my trapezoid, I've got area. I'm actually going to use a different color. Don't want to confuse you. Area equals 1/2 height times my base 1 plus my base 2. Let's see if we can find all this information. I've got 1/2. Well, my height is right here. It shows me with my right angle. So it's 4 inches. My base 1 and my base 2, again, we can flip-flop these. It doesn't matter. It's still going to work. But base 1 would be 6 inches. And base 2, there's nothing here. But as you can see, if you look straight up, this line matches identically, so it would be 10 inches. And 6 plus 10, I'm going to fill in all of this real quick. 6 plus 10 gives me 16. Keep going. 4 times 16 gives me 64. My last step is to take 1/2 times 64, or I could divide my 64 by 2. Should come up with 32 inches squared. So now I found the area for this shape right here. Now what I need to do is add my 100 inches squared plus my 32 inches squared. I should get 132 inches squared for my total area of this composite shape or figure.